So thank you for the introduction, and I guess we'll go ahead and introduce ourselves individually too. So hi everyone, my name is Yvonne. I'm a rising junior majoring in computer science. And I'll pass it off to Jayesh.
Hi, I'm Jayesh. I'm also a rising junior majoring in EC and stats.
And hey, y'all, my name's Trayvon Helm. I'm a rising sophomore majoring in electrical and computer engineering.
Awesome. So I'll go ahead and first get into the background and motivation of why we took on this project to begin with, and I'll go ahead and pass it to my teammates to explain a bit more. But as context, current intrusion prevention system, including Dukes, utilize web attack signatures to identify malicious activity and clients and to be able to block them, right? But that leaves networks susceptible to attacks that don't actually have the signature. And these are what we call zero-day attacks or unknown web attacks. And so our job throughout this project was to analyze 7 gigs of web traffic logs and engineer new features that we can use to help predict these attacks. And we ended up creating a scoring system to rank clients or users on suspicious activity. That way we are able to predict these attacks and block any malicious behavior. Go ahead and pass it off to Jayesh to talk a bit about the data that we analyzed.
Yeah, so when we were looking at our data, we roughly, so the primary data that we worked with was all the weblog traffic from May 1st. And when we mean weblog traffic, this is every single search or internet search that was made, whether a person, a redirect, or automatically for one date only. And this was roughly 2.5 GB of data just from a single day. And we later on analyzed the first 2 days of data from the June as well for our testing. And when we were doing our data, we had roughly 13 columns, but because we wanted to focus we want to make sure that we were able to develop sufficient features, we primarily focused on the URI path, the URI query, the status being the HTTP status code that's logged in every search, user agent, and I believe source. And the methods we utilized to analyze this data was first simple EDA, which we did to simply understand the data set better. And then we utilized machine learning techniques such as DBScan, NLP, KNN to establish what is normal and what is irregular behavior. And finally, we used statistical methods such as interquartile ranges and z-scores to find outliers. And I'll be passing on to Tribone.
So due to the complexity of our project here, our team kind of tackled various different features at once. Certain things just peeked out to us more than others. And so because of that, we figured we would make a scoring system so that we could combine all of our different features that we were creating, because some of us would target URI query, some of us would target time, some of us would target status codes. It made sense to just combine them. And towards the end of the project, we were actually able to create a very basic scoring system where we were able to look at unweighted means along with a test run of weighted means. And we were able to find attacks that were indeed suspicious and things that we were able to make detections for. So our project lead, Eric, actually went through over 600 of the most suspicious client IPs that were detected by our scoring system, which is really awesome of him. But with that, we were able to make this graph, this scatter plot that sort of shows some of the things that we deemed legit, an attack, or even we don't know. And this graph sort of kind of shows through its clustering how, although we can see some very interesting patterns in the data that we would love to analyze further in the future, we can kind of see that legit stuff, no judgment, and attack things are all in the same spots in certain points. And this kind of just goes to show that just because something is an outlier doesn't necessarily mean that it is an attack. And just because something is in the average doesn't necessarily mean it's legit. Our data is very complex since we are dealing with user behavior here. So it is a bit difficult. However, we were able to make things happen here in our results. We weren't able to find a way to detect unknown web attacks per se. However, we were able to create brand new detections for Duke OIT, which you can see here. And with these new detections, we blocked over 1,000 client IPs from over 80 different countries, which is very exciting. if I do say so myself. But some things we would like to do in the future here with our work here. One, we would like to do more exploratory data analysis. We just want to see what other things we can come up with, explore different features, maybe combine some of the columns and see if we can create brand new methods of tackling unknown attacks or getting different detections as well, either or. And another thing we would like to do is improve the scoring system, because there are definitely some biases here in the scoring system as we have it now. We do have a lot of legit bot activity coming through. So we would love to minimize that, perhaps by adjusting our weighing system to improve it so that it's not as biased and it can find even more attacks. So finally, I would just like to acknowledge all the people who helped us out on this project. I would like to acknowledge our project lead, Eric. He was instrumental to our project. Without him, we wouldn't know what was legit and what wasn't legit. He was always there to help us out. So greatly appreciate Eric. We'd like to thank our project manager, Pranav, for always being there to give us brand new ideas and new methods to try out on our data. We'd like to thank Cisco for sponsoring this project and also for giving us 3 mentors to help us out, Asif, Jamie, and Mike. They were greatly appreciated and they helped us out tremendously. We'd like to thank Ian Hagraff for giving us another perspective with the weblog, since he specialized in a different area in them. And we also like to thank Zachary Absberg from Proofpoint for taking time out of his busy schedule to meet with us and to just give us his take on what we were doing. And with that, we are happy to answer any questions that y'all may have.
Thanks a lot for a really nice presentation. I'm really glad you were able to meet with Zach. That's actually pretty exciting. So I guess I'll kick off with a question. You had mentioned, so you've developed all these methods and you have some rates of false positives and some rates of false negatives. And this is, of course, completely understandable. And you mentioned sort of there is some opportunity to improve this, of course. And I was wondering if you were going to take the next step on this, if you were going to work on this for 2 more weeks, five more weeks, what would the next model be? Like, what is the next piece of information that you would want, or what is the next sort of feature you would add to your analysis that would be able to sort of improve this by a step? And maybe my other question is there some data that you feel like you might be missing that if you had it would help you sort of refine this, refine your models more?
I can take the first question on that. So our next step would have been to better perfect that scoring system by trying to weed out the bot, the false positives, as you mentioned. We had a preliminary idea to create a scoring system in hopes to catch these bots. And we had given a start in the beginning, but running out of time, we think that we weren't able to quite get it in. But if that was our next step, I think weeding out the bots by creating that scoring system and look at what new features can indicate if this bot is malicious or benign would have been our a good step forward. In terms of data we would need to, I guess, further complete this, I think one recurring theme for us was it would have been awesome to have labeled data, to have a good understanding of what's baseline and what's abnormal without us actually having to go through and label it ourselves. So that would have been an awesome help. Trayvon, Jayesh, am I missing anything else?
I can just add quickly as well. I think one of the biggest things that we only realized at the end of the project, and that was Zach who helped us realize that, was that the way that we calculate outliers is something that we can change. And one of the key things is that because we're trying to detect unknown web attacks, we're trying to establish this pattern of what looks like normal and what necessarily doesn't look like normal. And just because something looks irregular, it doesn't mean that it's suspicious. And that's obviously why we have multiple features, and that's why we're looking at all the different scores. That's why we're playing the different weights. But even when you're trying to detect what's an outlier, the way that you go about calculating distances as well is something that we can change, and the way that we calculate outliers. So there's multiple ways. There's a lot of different statistical analysis. And unfortunately, we didn't all get sufficient time as well to look at anomaly detection algorithms as well. They're especially designed to do so. So there's and we actually plan to continue the project hopefully throughout the semester. So there's multiple tweaks and multiple things that we can do.
Cool. Thanks a lot. Robert, you had a question?
Yeah, I was wondering, and maybe I was listening to the last discussion, and maybe you were touching on this a bit, but I was wondering whether it was possible to bring into the analysis an element of, if you like, guilt by association. So in a sense, OIT may have fingered already suspicious bad actors. And the scripts that you're looking at, to what degree are they similar to those? Could you make some sort of inference based on that?
I could go ahead and quickly answer that. I did try doing that early on in the project. I tried establishing a Bayesian network. So I unfortunately did not spend too much time on that because I thought it'd be more prudent for me to do more NLP. So I think the Bayesian network would be great for inference simply because you can essentially just establish like, okay, so you can build a Bayesian network where you could look at, so one of the big things that we found was that they were, a lot of times attackers were targeting specific files, like they were targeting specific security backup files or certain JavaScripts or CSS. And what we can do is that we can see, okay, if these client IPs are attacking these scripts, then we can look at the Bayesian network and see that if you're attacking one script, what's the likelihood of you targeting these adjacent ones? And then we could look at potential other client IPs that normally access this. And via this method, we could potentially build something which has an inference relationship. But this, and I simply chose a Bayesian network because I had previous experience. But I think it would require for us to do a bit more reading about like how to develop these inference patterns and how Bayesian networks work before working on this. But yes, this is a technique that we did consider.
Okay. I mean, I just tell you a story in a sense from another world. When I worked at AT&T, we had people who would take out telephone service with no intent to pay. They would claim to be a flower shop. They would really be running a phone sex line. And one of the things that we discovered was that these people formed their own network. They talked to each other. And so when somebody took out service, we actually scored them based on who they talked to. And then we proactively investigated them. And the woman that led that project is Corinna Cortez, who is the technical lead for Google New York now.
I think that would be a very promising avenue for us to continue down. Thank you.
I had a quick question. I was noticing on the graph in the bottom center that I think all, if not most, of the suspicious clients above, I think 4.0, it looks like, they were all attacks. Is that interesting? Like, is that something where if you ran the scoring data against, or the scoring algorithm against more data, you'd find a lot of them around, greater than 4 for that weighted score?
I can attempt to answer that. So we would hope to see that with a higher weighted mean that it would be more and more suspicious attacks. Luckily in this graph with these client IPs, that was the case here. However, that is not always the case. I actually ran the scoring system yesterday with some new features that I was sort of beta testing a little bit. And some of the really high weighted mean ones, I was able to pick out and see that they were actually legit. So that could just be a testament to I need to iron out some of my brand new features, or it could just be a testament that our weighing is a bit off. So ideally, a higher weighted mean would mean an attack. As you can see by the graph though, like underneath near that 4.0 port, we do 4.0 point, things do start to get a bit muddled. And with other experience, we have seen it does get a bit muddled. So ideally, yes. In practice, not as much. And there's definitely more work to be done there. So.
This project is really kind of fascinating for me from the point of view of kind of a almost like a theoretic game theory point of view, in terms of like, what if you have a certain type of attack, if an attacker is looking for a certain type of information or they're looking to achieve some goal, is it possible that they can always, what is the list of things you need to, given the data you have, is it possible that they can design an attack that can get that, or is it possible for you to always be able to block them? That would be a question I would have. And I guess in I know, and I'm not trying to get into the theory here, I'm just noting that it's interesting. And I guess one question I have for you all in terms of thinking about these attacks, and maybe without telling me what it is, given all of you've done to detect these attacks, do you now have the thing in your head of, oh, well, if they attacked us this way, I don't have no idea how we would detect that? Or if I attacked us this way, we haven't dealt with that, but I know at least how I'd figure that out.
I think it comes down to we don't know which way though, right? Because our entire project is based on finding exactly what way they're trying to attack us. And so because of that, I think the question really becomes, can I detect exactly if this is even an attack, right? If this is an attack, then I can find that way, if that makes sense.
Well, and let me flip the question a little bit though, because if you were going to be the attacker, given what you know about defense, could you design an attack that couldn't be defended against?
Tricky.
I can try and actually take that a little bit. I know for me personally, looking through the web logs, there are definitely some attacks that I've seen are really loud, that are just kind of out there, and you can kind of tell they are there. But when it's very discreet, or when there aren't a lot of hits to the web logs, I know for me it's a bit harder to tell whether it is an attack or not, and that's where I sort of have to go to Eric a lot and be like, hey, I found something here. What do you think this could be suspicious or not? So there, more professionals could probably tell those a bit better, but for me personally, that's a little hard.
And I think we can also all attest that even after discussing with Eric, we're still not clear about whether it's an attack or not. I think that's the really interesting thing. It's just like I think a lot of times it's really hard to tell whether something is genuine or not, because a lot of times, like, I think we literally, like, just 5-10 minutes before a presentation, like, I have a little quiz that I've made, and I'll get everyone to play it. And I was just like, hey, can you guys test run? And we were arguing about one of the answers, whether it's an attack, whether it's suspicious or not. And it just is the nature of this. It's just like, it is often hard to tell. Yeah. And I think there is always going to be that element of, you're only going to detect that's an attack 5 or 6 years later, maybe, because some attacks are really discreet.
Got it.
And they're not that, they don't crop up, but yeah.
I'll actually jump in on that as well. So when the team came to me and it would ask, is this an attack? Sometimes I could look at it and say, yeah, that's an attack, or that's not an attack, if I already knew about it. Quite often, I had to go and actually start researching it. And sometimes that actually took multiple hours of digging into it. We actually found one of the attacks that was turned into a detection and is now being used to block IP addresses that are trying to attack the network, is trying to attack a specific utility called Adminer. And as a result of looking at that data, we actually found an install of Adminer on the network that is being used legitimately and was actually deliberately left open with appropriate security controls around it for people on the internet to use. Which that took a lot of looking at to figure out that that was in fact intended and legitimate and probably okay. So it's not necessarily a case of we can look at something and say this is an attack or this is not an attack. And that's made worse by the fact that what the target of this project really were what are called 0-day attacks. The attacks that the bad guys out there know about and are using, but the defenders don't know about. So if we know what an attack looks like, we can detect it and block it. If we don't know what an attack looks like, we don't have a way of detecting it and we can't block it. We might get lucky based on the multiple layers of security that we put in place to be able to catch it at a different layer, but we won't necessarily be able to catch it in these logs if it is actually a 0-day attack that we've never seen before. Some attacks you can look at and say, yeah, that's pretty suspicious. Some of them are not going to be obvious just looking at the logs.
Yeah, that makes sense. It actually makes me wonder what are the goals of these attacks? Like what is it that they're trying to accomplish?
In a lot of cases, the attacks that we detected here they're just trying to get a foothold on the network, not even necessarily because they're attacking us. They're just trying to get a server that they can use for their purposes, whether or not that's to send spam, to host whatever content they want to host that's not legitimate. There's a bunch of different reasons that are don't necessarily have anything to do with us. Those aren't necessarily the ones we worry about. Those are nuisance attacks. They take up time and they take up energy, but they're not that concerning. It's the attacks that are deliberately targeting or trying to get into our network specifically so that they could put ransomware on Duke servers, or they could in some way go for Duke resources specifically. There's not an easy way to tell the difference between those two, other than generally you kind of get a feel for this kind of attack is probably just a drive-by attack going for whatever they get, and this other kind of attack is more likely to be targeted. But there's not necessarily a hard line between this is targeting us and this is targeting whoever they can get.
Yeah, thanks.
Hi, I have a question about your detection algorithm, or rather next steps, which is that it seems like your detection algorithm has like 3 distinct territories, which is one, you have stuff that you can immediately identify as being legit. And then you have a distinct territory where you can identify traffic as being really blatantly bad. But there's also that middle ground where you have a lot of uncertainty as to what it's actually supposed to accomplish, whether it's good or bad. What are some techniques that you can envision OIT adopting for traffic coming out of this realm as a further step to determine legitimacy or to slow an attacker down when you're not sure about their intent?
I think I can try to answer your question about legitimacy. Something that's really helped us overall and why we chose to design our scoring system based off of the client IPs and not individual web queries is because we have a longer history over what a certain user is doing. And given that context, we're able to make greater interpretations about their behavior. Since our data was limited to 1 day's worth, that means that we weren't able to track what they were doing beyond that 1 day. And so off the top of my head, I would probably suggest tracking that client over 1 day to see what the behavior before and after was, to offer more context as to if they were indeed malicious with a 9. I think Trayvon, Jayesh, do you have anything to add to that?
Yeah, so normally what we could do is that we can sort of, like, as Yvonne said, it's most of the time it's about analyzing the client IP behavior and how they behaved over a period of time. So for example, we can analyze the user agents and we could look at how common are the similar user agents. We could look at the number of status codes. If there's a high proportion to 400 and 500s, that's normally indicative that it's normally an attack. And you can analyze, we could do a query where we could do a group by, where we can do the count of number of the bytes, the status code, and whether they're accessing the same website or not. So using a combination of these techniques, we can try to ascertain whether it is an attack or not. But normally, because a lot of the time as well is that there's not a large history for each of the client IPs, and then it becomes even more difficult to analyze. But these are normally the techniques we use.
I think there was also a second part to your question. Could you repeat that? Sorry.
Sorry, I had to find the unmute button. The second part of my question was pretty much like, are there anything that you could recommend OIT do in order to slow possible attackers down while you're trying to gather more information on what attackers or minorly inconvenience good traffic while you're trying to establish the legitimacy of this new traffic?
That's a good question. Give me a moment to think about that. So slow down attackers. Eric, if you want to take it away, I really appreciate it. But I guess off the top of my head, I'm sorry, go ahead.
Sorry, go ahead.
Okay. I know distinctly back when this project first started that Eric mentioned honeypots on networks. Something that wasn't quite honeypots, but that attackers would see and they would go try to access a file. If I were to recommend something, I would probably recommend something along those lines where you can sort of bait your user into accessing files that they're not supposed to identify them. Maybe that would direct them to spend more time on something else that isn't even worth attacking. Maybe that would make it easier for us to identify if they're malicious or not. That's something right off the top of my head, but Jayesh, do you want to go ahead and take it away?
I was also gonna say, like, there's some things that I mean by like stuff that we're doing right now, like trying to analyze weblogs, trying to see that what is the sort of like a deviation from normal. That's one thing that we're doing, because then we're able to largely filter out what is legit and what's not legit, because then we're reducing the number of weblogs that we need to analyze. But also it comes to a point where it's about educating the people who are also surfing the web about making sure that please don't try to click on dodgy emails. Please try to make sure you don't go to suspicious websites, because this sort of like making sure that users are using the web responsibly as well is one of the big things as well, in my opinion. But Eric probably has more.
I'll jump in. The idea of slowing down traffic is one that has been looked at in information security over time. It's kind of problematic because in a lot of ways, the difference between an attack and not an attack can be fairly subtle, and the tolerance for false positives in detecting attacks and therefore blocking traffic. False positives means you're blocking legitimate traffic and you're stopping legitimate use of the network, and the tolerance for that is really, really low. One of the things that we have to take into account when we're turning the things that the team has found into detections that are built into our blocking system is making sure we have the threshold set that it is very unlikely that we'll catch legitimate uses. Because if we run into a situation where we are getting a lot of complaints about legitimate traffic that's being blocked because of our detections, we will eventually lose the ability to block that traffic because the cost to the legitimate users of the network is higher than the benefit we get from blocking the traffic. So there's an interesting political effect there. And it's not quite that we can have zero false positives, but we want the rate to be really, really, really low.
Thanks, everyone.
I know.
This is sorry, Trevon. We're starting. I think we need to transition over to the next talk. But thanks a lot for the really lively discussion and great answers. And thanks all for the really nice questions. So let's thank the team virtually. A round of applause. Congratulations on completing your Data Plus summer experience. And a really nice poster. So